Running. Welcome everybody. So we're going to do some notes on 2-1 functions. Okay, and you probably dealt with these a little bit during Algebra 2. Okay, the one thing you may not have dealt with in Algebra 2 is function notation. We're going to talk about that. We're going to talk about the concept of the function as a machine. Okay, so we have this magic box, and in one end there's a little tube that goes into the box. Okay, and on the other end there's a little chute that comes out of the box. Okay, and my drawing is not beautiful, but that's okay. Okay, there's a little chute that comes out. And basically, we do this. We put a number in, and another number comes out. Let's say 8, okay? So if we put in 3, we get out 8. Let's do another one. Emma, I should use the magic pen for this one. I think that would be great, because then it'll go away and then I don't have to erase them. Okay, so I'm going to find the magic pen somewhere here. Magic pen. Okay, so I put in 3. Let's do another one. How about 5? I put in 5 and 12 comes out. Okay, 5 and 12. 5 and 12. See, the machine does something to it, right? Something happens in here, in this function machine. I like this look. It's nothing new. I certainly didn't invent this, but I like it. And we can do more. Okay, magic pen. Good. Let's put in another one. How about 6? Guess what's going to come out? 14. Yeah. 6 and 14 come out like that. Magic pen. I wrote that one in magic pen, 6 and 14. Let's think of another one. 7 and 16. 7 and 16. Can you see it? List them out. Those middle 3 will help us. 5, 6, 7, 12, 14, 16. So let's think about what kind of a function is this. Well, we can graph it. We have tables and we have graphs. Maybe I should move that down a little. We've done this before. Oh, that's not what I wanted. It's not what I wanted. All right. So we had 5, 6, 7. How are we doing, Sean? Staying with it? Okay. 12, 14, 16. 5, 6, 7. Boom, boom, boom. What kind of a function does that appear to be? A linear, yeah, good. Appears to be a linear function. And we don't know what kind of a scale we have here precisely, but it does appear to be a linear function. Another way we can look at that, you had that in Algebra 2. Another way we can look at that is taking the first difference. First difference there is 2. Difference there is 2. And then, if we know the common difference on a function, we really, really, really want to find the 0 term. Okay? ... 0 term. If we know it's a linear function, we know that first difference. What would the 0 term be for this one? What would the 0 term be? Figure it out. Find that 0 term. Florian? It's 2. Where did he get that nonsense, Hannah? Yeah, and he kept. Did he work backwards? There's other ways to do it. He took the differences. Good. Okay. So it is two. Is that how you did it, Florian, or did you do it a different way?
I figured out the equation.
Oh, you figured out the equation from here. Did you do it like y equals mx plus b and plugged in some numbers? You knew, well, we knew 3 and 8, so where does the 8 go? If you have 3 and 8, where does the 8 go? To the y, y equals, and we said this common difference was 2, so that goes in the slope or the m, 2, and then 8 is joined at the hip with 3, so that goes in there, plus b. Is that how you do it, Florian? Very good. So we have 8 equals 6 plus b, so b has to be 2. So what would that equation be that would model this data? Whole thing. Y equals, what would that be, Luke? 2x plus 2. Very good. 2x plus 2. And that, ladies and gentlemen, is a function. That is a function. Okay, how cool is that? So, you can. So that's a function. And I'll just keep talking while she's doing that. We're multitasking. Yeah. And we are going to, generally when you're graphing, you'll use the y. Generally when you're graphing, you use the y. It's over here. Boy, Ms. Osborne is making it tough on me, I'll tell you guys. Yeah. Okay, so generally when you're graphing, you use the y, but when you're not graphing, when we're just talking about functions, I want you to start to get used to function notation, which looks like this. Some function, f, you can name it anything you want, of x equals 2x plus 2. And a real note here, and even if you're not paying attention, start paying attention. This is the name of the function. Back. Where did it go? It ran away. Ah, it's here. It says f of x is the name of the function, not, this is a biggie because people goof this up a lot, not f times x, okay? It's the name of the function. It could be g of x equals 2x plus 2, or h of x equals 2x plus 2. It doesn't matter. That's just the name of the function. Okay? And what is nice about function notation is we can say f of 3 equals 2 times 3 plus 2. So then we would say f of 3 equals how much? 8. Okay. Who used this in their Algebra 2 class previously? Okay, good. Some of you had function notation. That makes our job a whole lot easier here. Okay? That's wonderful. That's really good. Okay? And there are lots and lots and lots of types of functions we've talked about previously. We talked about linear functions. Of course, look like a line. You've dealt with quadratics, of course. What do they look like? Quadratics. What does the graph look like? Izzy? Yeah, a graph looks like a parabola, either upside down or right side up. Quadratic. That's like y equals, 2x plus 5. This is like y equals, 0.5x squared plus 7x or whatever. It doesn't matter. Plus 3. Those are real typical. You can have cubics. They look like that. Whoa. Y equals x cubed minus, 7x squared, whatever. Things like that. Cubics, quadratics, linears. These are the ones we will deal with the most in this class. And hopefully some of this is review, but some of it may be kind of new. Okay? Almost done. You all are doing an amazing job, and I will shut up here very shortly. Okay? Questions so far on what we've covered? Functions as a machine, different types of functions. Questions so far? Love questions. Okay. Got it? Okay, I can. I can and will. Okay? Now, if you have a function, in order to have it, and it can be really, really goofy, crazy, wild, nutty, anything like this, as long as you can draw a line, a vertical line, and you've seen this before perhaps, it's called the vertical line test, and if I take this line and slide it along here, if I only hit one point everywhere, then it's a function. But like right there, that worries me a little bit. I might be hitting 2. Okay? I'll say, I'm going to use a different color. I'll say fails vertical line test. So it is a relation not, I'm going to get rid of that. It is a relation, not a function. Okay? If it fails the vertical line test, if you can draw this green line anywhere along here and you hit more than one point, more than one intersection, even there it would fail the vertical line test, then we'd say it's a relation, not a function. Question?
I was going to say, so even with like vertical lines, if that vertical line intersects is not on the graph, it would fail.
It would fail the vertical line test and not be a function. This part here is all fine, well, maybe a little bit there. It would not be a function. Let's do some others. A couple of quick ones. How about the good old sine function we know and love? Why is this a function? Does it pass the vertical line test? Yeah, even there, everywhere we're going, there's just one intersection. Okay, so that's a function. But then sometimes you'll see stuff like this. You'll see things like that. That's a relation, because look, fails the vertical line test. You have an intersection there and an intersection there. That's bad. That gets confusing. Okay? In terms of coordinates, what would this look like? What would this look like? Like if this is on a coordinate plane, XY coordinate plane, and this is, I don't know, 4. And this is 2 and 5. So the coordinates here are what? 4, 2, good, and 4, 5. If you see this, instantly not a function. In terms of coordinates, not a function, because there is 4, 2 and 4, 5. The same x has two different y's. The same x has two different y's. That's bad. Okay? Almost done. Almost done. Maybe I should write that down. The same x is assigned to two different y's. So here's a question for you in closing. If I have a parabola like this, and I have -4, 3, and I don't know, it doesn't matter, 2, 3, is that okay? This is a function. Ran out of space. This is a function. Okay? It's all right to have the same y for two different x's, but it's not all right to have the same x for two different y's. Fails the vertical line test. Okay, how'd we do? How many minutes? How many minutes are we in? That was 16 minutes, 42 seconds. You all were a great audience. I am going to stop talking now. I will post this to our Moodle site tonight. And